Okay, we're going to backtrack a little bit and go back to when we were learning how to solve equations. And we're going to use a lot of the same rules that we were using when we were solving equations. But now what we're going to do is we're going to solve inequalities. And if you remember, inequalities were these symbols here, which is red. That one is greater than. This one is less than. This one is greater than or equal to, and this is less than or equal to. If you notice, those last two have the half of an equal bar. That's where the equal comes into play. So if you're asked to solve inequalities, like this one, t plus 12 is greater than or equal to 8, then what I want to do is I want to isolate t. I want to get the variable by itself. And the same rules, the same procedures apply when you're solving equations as you do when you're solving inequalities. So the good news is this one should be pretty easy. I'm just going to minus 12 from both sides. I didn't leave me enough room. But I'm going to minus 12 and minus 12. That goes away. And I'm left with t is greater than or equal to negative 4. Now, we're going to graph that solution on the number line. So my object number is negative 4, so I'm going to go to negative 4. And I'm going to put a circle on negative 4. And then what this says is t, whatever number that is greater than or equal to negative 4. So numbers greater than negative 4 would go this way, but it also could be equal to negative 4. So I'm going to put a circle on negative 4, and everything that's bigger than negative 4 goes this way. So I'm going to draw an arrow representing that. Okay. Now, with regards to my circle, the solutions to this would include negative 4 because of the equal bar, which means I'm going to show that I'm including negative 4 by closing that circle in. Okay. So when we make these circles on our solution numbers, here's the rule. You're going to use an open circle if it's greater than or less than, meaning we do not include the solution number, and we use a closed circle if it's greater than or equal to or less than or equal to. So just know that if you see this equal bar, you're going to close that circle in. Okay. So let's look at number 2. For number 2, I would take away 12 from both sides. So if I minus 12 and minus 12, that would leave me with n is greater than negative 24. Minus 12 here goes away. Minus 12 here. Negative 12 minus 12 is negative 24. So I need numbers greater than negative 24. Well, numbers greater than negative 24 are this way. Remember, negative numbers go backwards, so these numbers are smaller. So I'm going to put a circle on negative 24. I'm not going to include negative 24 because there's no equal bar. So the circle says this is where we start, and I'm going to go this way. Numbers bigger than negative 24 this way. I'm not going to include negative 24 because it can't be equal to negative 24. It has to be greater than. So I show that with an open circle. Okay. This one, minus 9 from both sides. This is a tricky one. I'm actually going to rewrite this one up here. 16 is less than or equal to h plus 9. To get h by itself, I would take away 9 and take away 9, and I'm left with 7 is less than or equal to h. Now, if you notice this, the answer is written backwards from this. The variable's on the right-hand side. So if I read this backwards, I would read it h is greater than, remember the alligator always eats the bigger one? H is greater than or equal to 7. So numbers greater than or equal to 7 has to go this way. Okay, you have to be very careful drawing your arrows. I know that the arrow is pointing to the left, so we think that it's always going to go to the left, but that's not always the case. If the answer is backwards, meaning the variable's on the right side rather than the left, then the arrow is going to be backwards. Let's look at number 5. Number 5 says 3r plus 6 is greater than 4r. Well, I got a variable on both sides. Remember what I do? I need to eliminate one of them. I'm going to bring the child to the parent. So if I minus 3r here and minus 3r here, I'm going to be left with 6 is greater than 1r or just r. See how this is written backwards? I'm going to have an open circle on 6, and this says that 6 is greater than r or r is less than 6. So this would go this way. Okay. All right. Let's look at a word problem. The sum, adding, of a number and 8. So the sum of a number and 8 is less than 12. Bingo. Take away 8 from both sides, and I've got n is less than 4. Okay, so let's look at another couple of examples. Let's look at number 2. I would add 12 because it's the opposite of subtraction. So we're just doing the opposite of the operations, just like we did when we were solving equations. So I would add 12, and I would get n is less than 18. If I add 12 here to get that to go away, add 12 here, I get 18. N is less than 18. Let's look at 3. 6 is less than g minus 3. I would add 3 to both sides, and that would give me 9 is less than g. Add 3, make that go away, add 3 here. This one's written backwards, so the arrow's not going to go to the left. This says g is greater than 9, so my arrow would go that way. Okay. All right. So one step inequalities, you just do the opposite of the operation that's happening. Same thing in a case like this. Okay, so now we're going to be, it looks like all of these are multiplication problems. There is one special rule you have to remember when you're solving inequalities, and that is this rule. And you will be tested on it, you can guarantee it. If you ever multiply or divide both sides by a negative number, you must flip the inequality sign. Okay? If you ever multiply or divide both sides by a negative, let's look. Number 1. This says 25 times g, so to solve that I would divide by 25. Both sides. So what I'm divided by here was positive 25. It doesn't matter that that number was negative, the 100. It matters the step that I took. What I did was I divided by positive 25, so in this case, I do not flip the sign. It doesn't matter that my answer is negative. It doesn't matter the number I started with. It matters right here the step that I take. Here, I would divide by negative 2. Now I'm taking the step, I'm dividing both sides by a negative number, so in this case, I would flip the inequality sign. And 9 divided by negative 2, if you put it in the calculator, it's negative 4.5, but I could just leave it as a decimal. I don't have to graph it, so I can just leave it, as a fraction. Look at number 10. I would divide both sides by negative 5. I'm dividing both sides by negative 5, so I would flip the sign. Negative 30 divided by negative 5 is 6. I'm going to flip the sign, and there's my p. Okay. 15. 15 is a division problem. It's dividing by 4. The opposite of division is multiplication. So just like we did when we saw equations, I'm multiplying both sides by positive 4, which means I'm not going to change this sign. So 4 times negative 3 is negative 12. These cancel. Remember, that's the reason I do that. And there's my solution. Okay. So about as hard as it might get. You got to remember that rule, the golden rule. Number 2, n is being divided by negative 50. I can think of it that way. So I'm going to multiply both sides by not just 50, but negative 50, and that will cancel out the 50 and the negative and leave me with just n. We'll have to multiply by negative 50 over here. And 22 times negative 50 is negative 1100. And I multiplied both sides by a negative, so I'm going to change the sign. Okay. So remember these. Multiply both sides by the reciprocal. 5 over 3. This all turns into 1h. I'm multiplying both sides by positive 5 over 3, so I don't change the sign. And this would be negative 15 over 3, negative 15 over 3, which is negative 5. Okay, that is assignment 24.